So this histogram, I told you last time, I told you, for example, the number of marks are given. So for example, 50 students, the marks are given like 41, 42, 82, something like that marks are given. So what you have to do, you have to, x-axis, we have to give the intervals. So for example, here you give 0 to 20, 21 to 40, 41 to 60, 61 to 80, and then 81 to 100. So you find out, basically this is frequency or count. So y-axis will be always, in case of histogram, the y-axis will be frequency, or we can call it as count. So 0 to 20, you count them. For example, in this case, 5. There are 5 students. So like that, you draw the histogram, and this gives a picture of the class. This gives a picture of the class. So from this diagram, I can interpretation. So you see, majority of the students are in the class, are above their average. That many times it is going to happen. So majority of the students, they are in the average, and they are on the class average. Few students are bright students, and few students are they are slow learners. So this is how you interpret. So ideally, there are 3 types of histograms. 3 types of possibilities are there. So just for you to understand, just I will show. So this is one middle, just central type of histogram. So there is one thing which is skewed to the right. Skewed to the right means it will be like this. It will be like this. It is skewed to the right. Skewed to the left means it will be the other way. The histogram will be like this. So now there are 3 types of possibilities. Of course, there are many possibilities. It's beyond our thing. What we will discuss only these 3 types of. So now, suppose if the marks, now the quality, assume for this is an histogram for marks. That is the quality characteristics, 6 marks. So if it is marks, now we can say this class is a reasonably good average class. We can call it as an average class. Here the students need to improve. Here this is fine. The other side, this is fine because students are getting good marks. That is fine. Now in case of marks, if the thing is like this, if the histogram is like this, then it is ideal because many students are getting good marks. So you see, I'm starting from 0 and finally I'm going to 100. Intervals, I told you 0 to 20, 20 to 40, 21 to 40, like that. So 82, many students are there in the circle. So this is, quality is good because you see frequency x-axis, the number of counts. So the number of students from 80 to 100, they are more. That means the class average will be very high, quality is fine. The only thing is this place we have to improve. So that is what we have to interpret. Now suppose if it is like this, this is quality, there is an improvement. Here you see, y-axis I told you, y-axis is count, always histogram, y-axis is going to be count or frequency. So left hand side, 0 to 20, many students are there. So that means their improvement, quality improvement is required. So this is the way you have to interpret the histogram results. Now suppose if the dimension is the quality characteristics. Now this way we have 3 types of things. So now dimension. So for example, piston diameter is 50 mm. There is a tolerance and other things. Now if you measure them and if you create intervals and if you plot like this, if you have like this, because we know very well the piston should be 50 mm, exactly 50 mm. You don't want it more. If the piston diameter is more, there is trouble. If it is less, there is a trouble. So if it is oversized, the piston will not go into the cylinder. If it is undersized, leakage of gases will be there. So we want exactly. So middle we want them. So this line, this data, middle average should be more. Then only that is the ideal situation. Whereas both the cases, left side and right side, improvement is required. So we have to find out why there are defects like this. Whereas in case of this dimension, these two are not tolerated because both left skewed and right skewed are not. Either left skewed means undersized, so the right skewed means oversized. Left skewed, both of them are undesirable. So these type of things means there is some problem. Quality improvement has to be made whenever dimension is. In many cases it is like that. Many cases no. We don't want variation. Exactly. Most of the cases, only in case of marks, no, that is fine. Wherever most of the quality characteristics, average is, so deviation is not tolerated. So only this is better diagram, quality control. Whereas these two are not tolerated. For example, piston diameter is the quality characteristics. So in that case, the over left skewed and right skewed. This is right skewed. Left skewed. Both of them are undesirable because the count is more. Oversized components, the count is more. Here, the undersized components, the size is more. So these are all, we have to improve the quality. So we have to find out why it is becoming undersized. Whether piston, or whether during casting, what is happening, whether expansion cooling, whether they are taking properly. So all these things, so we have to analyze. So this is about histogram. So here you see, so this is a diagram you see, because 55 there are only one student, 90 there are two students, whereas there are 12 students, 70. So we can say, so here only one student out of the total, we can count what is the total number of students. 1 plus 5 plus, we can count. So out of them only one student has failed, so not 55, he's got 55. Two students have got 90. So this is an average class. So we can call this as an average class. So here improvement is required, whereas in this case, no problem. Two students more than 90 means it is fine. So this is how marks means it is like this. Whenever dimension is centrally here, this should be more. Centrally should be more. So this is about histogram. So next comes the paretogram. So paretogram says something about 80-20. So what is that 80-20? So if you take, I will show the next slide. Okay, this is the procedure. So I'll explain. So determine the method of classifying data by problem, cause. So either we can have cause or we can, non-conformity means defects. So you find out, classify the data based on defects. So we are going to find out, we are going to count them. So I'll show here. So for example, O-ring problem. So defect type is O-ring. So we have to count them. So first thing is we have to classify the defects. So first step in drawing the, whenever you want to do the Pareto analysis, first thing is we have to classify what is the type of defects. So O-ring is there, finish is there, scratch, pore seal, dent, dents, and other. So first you have to classify. That is the first step we have to do. And the next step is we have to count them. Frequency means count. So always remember, in case of Pareto diagram, count will come on the y-axis and the classification of defects will come on the x-axis. So here you see O-ring. So we have to count them and it has to be in descending order. That I will tell in the next step. Determine the method of classifying the data. So you know there are some defects. Any component you take, there will be some defects. Usually in industry there are many types of defects will be there. But in our case, no examination point of view, I can give some 4 or 5 defects only. So we have to classify the data. Non-conformity means defects. And then you find out what is the count. So here decide if dollars. So mostly cost, we will not consider that cost. Mostly frequency. Frequency means count. You find out for ranking them. So we have to ranking. The entire purpose of this Pareto analysis is to rank which defect is most critical. That is, I told you, in case of Pareto analysis, that 80-20 principle, we want to find out which is the vital few. That is 80% of the problems, listen to me carefully, 80% of the problems are due to very few defects, that is 20%. Whereas the remaining one is the useful many. Other defects are also okay. But this 80% of the thing, the 80% of the quality problems are due to only vital few. So that we have to rank them. So how do you do that? So we have to decide. So mostly in our cases, we will find out what is a count. So what is a count of each of the defects? So for example, in the next slide, I'll show you. For O-ring, it is around 75 defects. Frequency means counts. So for O-ring, there are 74 defects. For finish, there are 57 defects. For scratch, there are 52 defects. For pore seal, there are 34 defects. For dent, there are 33 defects. I don't know what is the other dents and other miscellaneous defects. There are 11 defects. Totally, then we have ranked them. So now descending order is very important. So we have to, so 74, 57, 52, 34. So all of them you keep in descending order. So that is going to be very important. So now moving on. First we are determining the method of classifying data. Then we decide the frequency or number of counts. And then we rank them. Collect data for appropriate interval or use historical data. That's what we have done. 74 is for O-ring and other things. Summarize data and rank order from largest to smallest. So that is going to be very important. From largest to smallest, we have to do. So 74, 57, finally 11. So in descending order, you place them. So when you want to draw the Pareto analysis, Pareto diagram. So first thing is y-axis count. So how do you decide? So this 300 because they are taken for this. Don't worry about the right axis. I will come to that later. So as of now, even no need to go to 300 because in our case the maximum is going to be 74. So even 100 can come here. So there is no need for 300. I don't know. They have made a mistake. You can even. So we have to find out the largest. What is the largest? That you add something. For example, 74 is there. You keep 100. So that then you all of them, all the non-conformity or defects, you place them on the x-axis. Usually in the examination, 6 or 7 will be there. And you know what is the number that will be given in the problem. I will give what is going to be O-ring, because we will discuss in another 5 minutes. We will discuss that website error, which you have seen in the last class. So you first draw the y-axis. You find out what is the maximum number of defects, and then you select a suitable scale, and then all the defects, classified defects or non-conformities, you bring it on the x-axis. Only thing is descending order from largest to smallest. You place them largest to problem. Then you draw the charts like this. And then finally you construct the diagram. Find the vital few problem area. So we have to find out what is going to be the vital few. So we have to. That is what 80-20 principle. So 80% of the problems are due to a vital few. The remaining 20% are insignificant. They are useful many. There are many. They are not significant. They are significant. So only that vital few we have to identify. And if you make improvement, your quality improvement will be like that. The idea is like this, because there are hundreds of problems. There are hundreds of problems, hundreds of causes, hundreds of problems, hundreds of types of defects. We are trying to find out what are all significant or vital few. They are going to be few in number. Only some defects are creating problems. So we identify them. The vital few problems we are trying to identify by plotting this Pareto chart. And then the remaining many problems which you need not attack, because when you want to make improvement, this major significant type of defects you identify, you make improvement, your quality improvement, your quality will be improvement will be much more. So that is going to be the idea. So now how to construct this right axis? So now what you do is, now you can find out what is the total. So 74 plus 57 plus 52 plus 34 plus 34 plus 23 plus 11. So you count them, it will come some number 500 or something. I think 70, 120, 170, 200, 230, 250, around 260 it is coming, 260. So now 74 by 260, it is around 20%. So you mark a point here. So this percentage, listen to me carefully, is cumulative percentage. So here it is not cumulative. O-ring is 74, finish is 57, scratch is 52. So here this right axis is cumulative percentage up to 100%. So I told you when I am adding, it is coming around 260. So this 260 will come here. So cumulatively what is it? 74 divided by 2, assuming I am not counted, 74 by 260, it's around 22%. You mark a point here. Then 74 plus 57. 74 plus 57. 74 means 81. 81 plus 51. 131. So 131 divided by 260. 131 divided by 260 is around 45%. Then you add all the three. 74 plus 57 plus 52. You add them. So 74, 50, 120, 130, 180. So 180. 180 by 260 is coming around 63%. So like that, all the cumulative. Finally, 260 by 260 will come. 260 will, that is 100%. So you draw so for each defect, cumulative percentage. So first 74 by the total, then 74 plus 57 by the total, 74 plus 57 plus 52 by total. Like that you do. Finally, total by total, then you draw a arc. Then from 80%, you draw a line. From 80% you draw a line. Draw a horizontal line. From 80% you draw, that's why Pareto principle 80%. Then you draw a vertical line. Now the left, whatever defects are on the left side, they are vital few. they are vital few, whereas the remaining are useful many. So without drawing also, you know very well. So these are all small numbers because descending order, when these are going to be small numbers. So without counting also, we can very well tell. So whenever 80%, even this point is also the first four activities: O-ring, finish, scratch, pour, seal. They are going to be the useful many 80%. Of course, I think they are not plotted properly. I think if plotted properly, I think it will come here. I think they are not plotted to scale. So this is how you draw the Pareto diagram. So now quickly that website discussion we will discuss, and we will go to the other. One second, I will go to the. So we will go to that website. I'll show that. Then we will go to the other tools. This is how I construct a Pareto diagram for the data given below and find the vital few file causes. So these are here the quality characteristic. The quality characteristics website errors. So this is one company. They are running a website. They are developing they are developing websites, and these are all the main problem. The quality characteristics website errors are there. Or errors are causes. They are finding out the causes. So they have counted frequency also. They have found out. They have found out the council. So 64, 57. So missing title. So this is the data given. So there are some 10 types of defects. 10 types of defects. Each of them, this will be given in the examination. I'll give 65. So now they are asking you to find out what are the vital few causes. So there are many causes, 10 causes. Out of them, which are the two? But without reading, we will tell broken links and spelling errors are there. But you have to construct the procedure, because procedure you must know. That is going to be very important. But without knowing also, you know very well, these are the number, because we are going to be in the descending order. This 250. So first thing is total. You find out what is the total. So 250 plus 120, 370. I'm not counting. I don't want to waste time. So 250, it will be around 400, 500. So 250, 370, 380, 390, 400, 420, 450, 500, around 565, something like that, 565. So 565, 250, this itself is okay, more than 50%. So broken link is the major problem. So what we have to do is, so first thing is you draw the y-axis. The maximum is 250. You select a scale of 270 or 300. So 300, then you put, you can have 300, 250, 200, to 150, 100, 50, and then 0. So y-axis, you see what is the maximum. What is the maximum here? Broken links is 250, and you can have 270. And the x-axis, you have to create some 10 divisions. So for each of them. So first, largest. So broken link should come in the first. Security warning should come in the last. So in the descending order. So from largest to smallest, you draw them based on this data. You draw like this, whatever that. So broken 250 means it will come here. The next is 120. That is spelling error will come. The third one is 250, 120. Third one is 65, missing title tag. So like that, you draw them. You draw all of them. The next stage is cumulative percentage. On the right hand side, you must draw on the right hand side. So what you do is you count whatever total. So 250 divided by total 560. I told roughly it's 560. 250 thing. So that percentage, first you mark a point here. So right side you have an axis. So this is for count frequency. Right side it's cumulative percentage. So 250 divided by 560, you mark for the first thing. And then for spelling error, 250 plus 120 cumulative. That's what 250 plus 120 points. So since it is cumulative, the curve will go like this. Finally, it will become 100%. The total by total will come. Finally, it will become 100%. Now, from 80%, you draw a horizontal line. And then you draw a vertical line. Whatever is there on the left, that is vital few. whatever is on the right side, that is going to be the useful many or trivial or insignificant. So we have to focus only on these things. So we have to focus only on these vital few activities. You can make significant quality improvements. So there is no need to worry about the minor causes. That is 80% of the 80% of the, there will be so many causes. In this case, there are so many causes which are not very important. For example, security warning, they are insignificant. Security warning, browser compatibility, missing alter tags, my incorrect use of headings. So these are all small type of errors, which you know very well. You know about website. So this you can handle. So whereas broken links and spelling errors are very crucial. Your website, if the spelling is wrong, your credibility will come down. If you see website, there are so many spelling mistakes are there, then your credibility, website credibility will come down. So this way we have to identify. That's what Pareto scheme. So ideally, you know very well, immediately you will find out what is the vital few after seeing examination point of view, because in real-time industry, there will be so many causes. That is the reason we have to draw the diagram, then we have to sit and we have to find out which are all going to be the major causes. So that is about the Pareto diagram. And we will go back to the other diagrams. So Pareto cumulative percentage of defects. So now moving on, we will move to the next type of thing. There is something called run chart. So this is also a very useful chart. Many times it gives. So for example, this is the chart which is given for the travel time. So for example, our VIT bus. So VIT bus Monday for example from some place. For example, from Tambram to our VIT University, it is going to get 32 minutes. 32 minutes. On Monday, it will take 32 minutes. On Tuesday, it will take 27 minutes. On Wednesday, it will take second. Like that, now you plot the data continuously, because this is because I'm telling you, all the 7 QC tools are basically for analyzing. Collecting data makes no sense. When you put them into some chart, then only you will try to understand. So now, if you see this is travel time for each day of a month. So Monday to Friday, they are collecting the data. Invariably, every Monday the time is more, 32 minutes. Whereas every Friday the time is very less. So then we will try to what is happening. The VIT drivers, they are going to their hometown, because Saturday, Sunday, we know VIT. One good thing about our institution is weekends we are not working. They are not working. So now this okay. COVID period, online classes we had many classes on Saturday, Sunday, even sometimes Sunday also. But of course, exams we have on Sundays. So from this data, why this reason is many times the drivers, they go to their hometown. So they weekend. So first day of the week, traffic also will be there, or maybe the whole driver. So like that, you try to interpret. You see the pattern. So every Monday you see it is 32 minutes. Whereas the other days, no, because their traffic is not a problem. So sometimes something like this we have to interpret. So this is a very basic quality control tool. So you have data, whatever. So y-axis is going to be the quality character. In this case, time is going quality. In case of bus, travel time is. So whatever may be the quality characteristic, that will come on the y-axis, and the x-axis will have the information. Usually time will be there, day or time, whatever will be there. So for example, shift also. For example, shift, you will see, shift beginning, the number of components will be more. So defects will be less. Shift end defects will be more. Night shift, the defects will be. All these patterns you must study. These things we are going to discuss in detail when you go for control chart. There that is different from run chart. There we are going to draw the average, and we are going to see whether it is near the average. So assuming the average is ideal, because all these TQM, please, I am telling you, variation is the problem. On this TQM, total quality everything should be near to the average. So that is the basic thing. But of course, MarkSlide is not like that. MarkSlide, it can be higher, it should not be lower. Okay. But whenever industry, when it goes, dimensioning, all these things, they have something called average. That is the ideal. More or less, both of them are not tolerated. So this is about run chart. Just to collect the information, put them into the chart, you try to interpret what is the cause, why this is happening, because there will be some pattern. So when you have data for a long time, for example, in this case, 1 month, a run chart, when you go for control chart, I'll explain. So from the pattern, whether it is cyclic, so here in this case, it is cyclic. So all these variations, they are cyclic. So you try to find out whether there is traffic jam or something like that. You can make some interpretation, and so that you can take some action. Maybe on Mondays we can start early, because whenever institution means we have to start the classes, because VIT also I don't know, 19 BME students, because many times the bus will come at 9:50, because sometimes we are not, because I'm coming from a very long place. Because if the bus has to come at 7:50 means we have to start a little bit earlier. Because students generally they made a complaint, because 8 o'clock teacher is not giving attendance. Somebody is not coming at 8 o'clock, attendance is not given, so it became a problem. So all the buses, they arrived at 7:50. So that the classes can start at 8 o'clock. So that the type of, so based on this run chart, we can make some quality improvement. So that is about run chart. Scatter diagram. So now, so you take any two variables. Now you are all very much familiar with automobile. So this fuel, gasoline, petrol, whatever it may be. So what is going to be the milliliter per mileage per gallon, speed, and you know the relationship is negative. And here there are three types of possibilities there. So here you are taking two variables. So any two variables which is of for our interest when you want to determine the quality. So when you want to, for example, if you take a two-wheeler, speed is also very important, and mileage is also very important, and you know automobile, you know very well. So here these two variables, you try to find out what is the relationship. So you collect the data, plot them on the x-axis. Only two variables. So based on, so that we can study the quality. We can find out what is the relationship between the two variables. So in this case, the speed of the automobile, the gasoline fuel mileage, we take it on the y-axis. And here there are three types of possibilities are there. When we have relationship, there is something called positive relation. And there are three types of relationship. When you take two variables, it can move like this, or like this. It can move like this, or all the points are not following something like that. All the points are like this. So they are not linear, and of course, so there are three types. When you take two variables and when you plot like this, there are three parts. So this is positive relationship. So one variable increases, the other variable also will increase. And in this case, now this is positive relationship, positive correlation. So the two variables are correlated positively. Now in this case, for example, when speed increases, mileage will come down. So you know very well. I think you guys know about automobile. You know when speed increases, naturally mileage will come down. So that is the basic thing. Because I'm not an expert in automobile. Because in most cases, when I studied automobile was an elective. Later I came into manufacturing, so I know only a little bit about automobile. So here when speed increases, mileage is going to come. So there is a negative relationship. One variable increases, the other variable decreases, means it's a negative relationship. Sometimes there is no relationship. So here examination, I have a lot of possibilities to ask hard questions here. So I will give two variables. You have to relate whether it is positive relationship or negative relationship. So just I'm giving one basic example. So you know very well, speed increases, mileage will decrease. So there is negative relationship. So this interpretation. So this way, hard skill question, there is a possibility. So out of three sets of question paper, one I can ask positive, one is no relationship I can ask, and one I can ask negative relationship. Like that I can ask, so that you have to think. Only thing is you have to know about that. So that field should be known. It will be basically, which is well known, I will ask. So that is about scatter diagram. Then there is something. So these are all products. So when it comes to products, these type of things, okay. When you can have these type of things. So when you have a service industry, this QC tool is very important. So the process what we are doing. So this is for a purchase order. So this is for a purchase order. So mostly, inquiry will come through telephone, fax, or letter. So now in even small industry in Ambattur also, they are having a computer. Now without computer, nobody can do business. Even if you want to make a shop, even that other thing, no, even that Google Pay also has become very popular. Even a small shop, their turnover will not be even 500, 600, but still they are also having that Google. So these are all nowadays become necessities. So every industry is having a computer. So they will log in, put the data, credit check. So this is very important because before coming to teaching, I was there in industry. So I know a little bit. What is it credit check? No, because nowadays everywhere, no, this is the problem. The company will give orders, but they will not give the payments for the previous month. So you check whether credit check is whether they have to pay any payments. So you ask for payments. You ask for payments. So that is very important. So many times, no, many industries they are ready to give orders immediately because they want material, but they will not make payments. But company will be very reputed company. Company will be they will not make payments. So you make a quality credit check. So if there is any credit they have to give, so ask them. Because even I was surprised on the other day I went to one shop, no, some company they have not made payment for 3 years. 3 years before they have supplied materials and they are not giving the payment. So if there is some credit, if there is some payment is pending, means hold it. So if there nothing is there, if a new customer, very well-known company like Sundaram Fasteners, no problem. First time they are coming directly, contract review, there is a procedure. Then you check inventory whether that material. Assuming it's a trading company, inventory means stores. Stores like you make a check whether the material is available. If it is available, then it's okay. Otherwise, you have to schedule the production and then notify the drawing, schedule the production, and then you can give it. So here, if you have a process flow diagram, you can find out where there is a problem in quality. So many times, even I was sometime many times now, customer will make a phone call immediately if you are responding. If the material is available, immediately responding, and if you're doing, you can make sales. So that is very important. For that, you should know because so many variety of material will be there. Whatever, if for example, if you take a paint shop, so many codes, so many types will be there. So if everything is known to you, then directly from the telephone, because customer immediately requires the com. So here, how do you do them? So by means of the process flow diagram, you can control the quality. So with this, I will stop for this class. So we will meet on Monday. So Monday, we will have the class. Monday, I'll be operating from. Anyway, it's online only. Monday, I will take the class. So just wait, I'll take attendance.